Yep. All right. Okay, grade 11, grade 12, sorry. Oh, my bad, sorry. Okay, you have done this already last year in AP, but obviously we just want it in our books again. And I don't know how the sounds of it, you can't quite remember. The specifics. Limit h tends to 0, yes. All right, then let's calm down. At the top, you say f of x plus h minus f of x over h. Now, this is on the formula sheet, right? We've just done limits, and we obviously know that if you have an h in your denominator, you can't just sub h equals 0 straight in. All right, so we're going to have to find what f of x plus h is, then subtract f of x from that, and hopefully we can somehow take out an h at the top so that we can cancel out the h at the bottom. Yes.
Ma'am, we are supposed to get the same derivative as if we were to just
Yes.
use the derivative.
Yes, exactly. So this is just a much longer way of doing it, but you can always check your answer. So once you're getting to your answer using first principles, you can check whether that is in fact the derivative. Okay, we're just going to do an example, guys. Maybe we should do an easier one and then a more complicated one, because they tend to ask the more complicated ones. All right, so examples. All right, guys, so this is a very simple one. I just want us to get back into using that formula. And guys, another thing, you only do this long method if they specifically state using first principles. They can also say using the definition of the derivative. That's another way in which they can specify. So let's add that there. So they can also say, or using the definition, I'm just going to write def in the definition of the derivative. Determine the gradient. Okay, so now I'm not sure how did Mrs. Rice do this for you guys last year? I'm not sure how she wrote it out, but I normally just do f of x plus h and f of x separately, and then I sub it into the formula, but you can do it all in once or in one thing, it doesn't matter. So I would just write f of x is equal to 8x. And obviously this one is quite simple, but it can get quite complicated working with fractions and all sorts of things. So then I've just found that it's a bit easier to not have like fractions within fractions, but it is up to you. So if you are doing f of x plus h, then wherever you have x in your function, you're going to replace that with an x plus h in brackets. And this obviously we can simplify to 8x plus 8h. Now I feel like it's just less writing to do that in like these two lines as opposed to the limit h tend to 0, whole fraction thing. Okay, once we have f of x and we have f of x plus h, then you're going to say therefore, oh, and we remember that the gradient of a function is the derivative, hey? Sorry, that's something that I didn't say. I just kind of assume that we know that. But the gradient of a function, any function, is always the derivative. So when they're asking for the gradient, they're essentially asking for the derivative. Okay, so then we're going to say f dash x is equal to limit as h tends to 0. Is it fine if I don't rewrite this thing again? It is right there at the top. All right, so now we're going to say f of x plus h, which we've just simplified there, is 8x plus 8h minus f of x, so minus the original function. So minus 8x, and that is all over h. Now guys, do we notice that 8x minus 8x is 0? So you could actually just do that. All right, they cancel each other out. What would I be left with? 8h over h. So I can cancel out those h's as well. So what would this simplify to? I am going to write it as a separate line, but you don't actually have to. Just there's a lot going on, so I'm just going to do it. But it's fine if you just jump straight to the answer. So this would actually simplify to just the limit as h tends to 0 of 8. And what is that, guys? There isn't even an h for us to sub in. All right. So the answer there would just be 8. Okay, very easy. Now I'm going to give you guys this one to do on your own. Get those brains working. Let's not do an x cubed. Let's do this one rather. Oh, guys, just quickly, sorry. We do know that the derivative of 8x is just 8. So we are supposed to just get 8 as our answer. Okay, so that's what you were saying, Paul. You can always do that checking afterwards. All right, so from first principles, determine the derivative of f of x equals 2 over x at the point where x is equal to 2. Now, guys, if your function is 2 over x, what is f of x plus h going to be? 2 over x plus h. So in your whole equation, you're going to have 2 over x plus h minus 2 over x all over h. So you have a compound fraction. And what did I teach you? What is the best way? Quickest way of getting rid of a compound fraction? Multiplying the top and the bottom by the LCD of the smaller fractions. Okay, so you do that straight away, and then you're working with something that's simpler. Okay, now they're saying at the point where x is equal to 2. So you get your derivative, and then afterwards, you're just going to sub in x equals 2. Okay, do it on your own, please. See if you can get it done. You're going to have to sub in x equals 2 into your expression for the derivative at the end.
And then you sub in h equals 0.
So you first sub in h equals 0, that gives you your derivative, and then you're going to sub in x equals 2. Yes. No, the two little ones, the small fractions. Guys, please remember to keep writing limit as h tends to 0 until you actually are using 0 for h. Okay, you do lose a mark for that if you don't write it every time. Okay, let's take a look. Okay, so there we go. You can have more steps if you wanted. Maybe less, I'm not sure about that, but okay, so there you didn't have to really write that down because it was very straightforward here. Okay, now guys, if we're looking at these two smaller fractions, do we agree that the LCD is x times x plus h? Right, so that's what you're going to multiply the top and the bottom by. So if we're multiplying that fraction by x times x plus h, do we agree that the x plus h's are going to cancel out? I'm going to be left with 2x. Minus, if I take this fraction and I multiply it by that, the x's are going to cancel out. So I'm going to be left with 2 times that bracket. Okay. At the bottom, you also have to multiply that by x times x plus h. So that is what you get. Suppose you could have put the h in front of the x as well. It doesn't really matter. That would have been alphabetical order. So yeah, that's probably better. All right, then I just multiplied the negative 2x, negative 2 into the bracket. Then we see 2x minus 2x is 0. And then we'll just have negative 2h at the top. So those h's can cancel out. So I would be left with only negative 2 at the top and x times x plus h at the bottom. Then if you make that h 0, you're just going to have x squared at the bottom. So negative 2 over x squared. Now, guys, if you had to find the derivative of this without using first principles, hey, of just 2 over x, remember you would say that 2 over x is the same as 2x to the negative 1, right? Then you would have to find the derivative of this. So what is that going to give you? Negative 2 times x to the negative 2. Isn't that the same thing? Negative 2 times x to the negative 2. So you would take that x to the negative 2 to the bottom, and it would be x squared. Okay, so that's a way of checking. And then just because they've added this extra bit in where they're saying at the point where x equals 2, you would then just have to sub in 2 to get that specific derivative. And guys, that would be the gradient of the tangent at that point. Right? Do you remember that? Tangents. Okay, so they can ask that as well. They can say from first principles, determine the gradient of the tangent to this function at the point where x is equal to 2. All right, then you need to know the gradient is the same as the derivative, and then you must sub in that x value. Okay, that's basically it on first principles. Mrs. Smith's notes are, I quite like them. Just quickly there, how important is it that you be able to find a derivative from first principles? Every paper one since the dawn of time has asked a 5-mark question in which you are asked to find, and it is true, they always ask it. So yeah, please, you do need to, if you can get these right, you're guaranteed those 5 marks. Up to you. Okay, I'm going to leave it at that. Guys, just quickly, in terms of other derivatives, do we need to do examples? I think you know how to do them, hey? You've been doing them for so long in AP. There's no chain rule, there's no product rule, no quotient rule, no trig derivatives, none of that. Guys, what you need to remember though, if you are not allowed, it's not that you're not allowed to use those rules, it's just the questions will be set up so that they're actually simple enough that you don't have to use those rules. So if you're looking at this, for example, 2 over x, I don't want you guys to think, okay, we've done AP and we have a quotient rule in AP, so I'm going to use quotient rule instead. All right. When you are in core, you need to understand that the derivatives that they're going to ask you to do will be of the form where you can get each term as you can split the whole thing up into separate terms and then do that, like they call it let me just see here, what did you call it? The power rule. All right. Where you can use this thing. This is the only thing that you will have to use in core when they're asking you to find derivatives. So whenever they've given you something to find the derivative of, and guys, they are going to give you fractions, they are going to give you ones that will have negative exponents and so on. You're going to first have to work on the expression to get separate terms and then use this rule on each term. Okay, yeah.
Maybe I'm wrong, but with the question, well, I know I'm definitely wrong, but like with the questions will not give a different like results for the example we just did.
It wouldn't, because the derivative of the numerator will be 0.
The derivative.
Because the derivative of 2 is 0. So remember, quotient rule is the derivative of the numerator times the denominator. So that will be 0x. And then minus the original first one times the derivative of that. Yeah, so it will, and then over numerator squared, denominator squared, sorry, over x squared. Yes. You would, yeah, but it's more, yeah. It will be easier to do it like that. Okay, guys. Thank you. We do need to practice all of these. So I'm going to just select a few questions for you quickly. I'm going to write it in this block. Let me just get my textbook. Yes. I have to ask what the birth is. Don't you want to just email her? Because she should know all of that stuff. I'm just quickly looking for my default textbook. All right, for first principles, we are looking at, oh my goodness, exercise. No, man. 8.4. Okay, guys, write this down, please. This is your homework for Wednesday. Okay, number 1, B and I. Yeah, I'll just give you those two. So these are first principle questions, those two. And then, oh, there's more. No, I don't want to give you more. Then we will look at exercise 8.6. There's a lot going on here. So page 204. Wow, I feel like no, guys. Let's do Yo, there's so many to choose from. I'm feeling a bit overwhelmed. Okay. Number 4. Five, 8F. And then just a couple of these ones because they're nice. Maybe 2. So let's do 6C. And oh, that's a nice one. 6N. There we go. Okay, get going, please. It is quite a lot, guys. I don't know how long it's going to take you. Maybe you'll fly through all of them. Maybe you won't. So let's use the time that we have. Yes, you may.